Welcome to the joint trimming setup operations webinar for Edge. Shortly, I'll share my screen here with you all and introduce myself. My name's Seth Jagger. I work here at Styles as the Edge instructor. I teach on large and small machines, operations, maintenance, experienced and novice. I'm joined here by Jody Tofton, who's our technical training specialist. Jody, if your mic is enabled, please introduce yourself.
Yeah, hello everyone.
Can you tell us a little bit about yourself, Jody, and being with the company?
I was actually a technician for 2 years, and then I started into this new thing called technical support, and I've been with Styles along with the Edge team for almost 25 years now.
Oh, nice. Well, thanks, Jody. Let's get started. First, let's talk about what is the pre-milling station. So the pre-milling station is going to be used to remove material on our workpiece before we get glue on the board, before we put edge banding on the board, right? And what determines how much that pre-mill cuts is our in-feed fence. So the maximum amount of material that I can remove on newer models is 3 millimeters, and on older models would be up to 5 millimeters. I also want to emphasize that adjustments on the pre-milling station itself, as far as motor adjustments, are not common. So what are the pros and cons of using the pre-milling station? Because I've run into a lot of customers, some that use the pre-milling station, some that don't have it equipped, some that do have it equipped, yet don't use it. So let's look at some advantages. It removes loose core in the board, right? So we're gonna rip and tear out any loose core that won't bond well. We're going to leave a milled edge, which is going to be different from a sawed edge. It's going to remove any warp in the board up to my maximum of 3 millimeters. It gives us the ability to rerun edge banding that has been put onto the board up to 1 millimeter. And we use 1 millimeter because anything greater than this could cause damage to the tooling or damage to the station itself. So as long as our edge banding is less than 1 millimeter thick, I can rerun that back through the pre-milling station, which is going to remove the edge banding off of the board. But please note that by doing this, depending on edge banding, whether it's PVC, whether it's laminate, whether it's veneer, I'm going to reduce the tool life on my cutters, plain and simple. The fifth advantage, removing scoring saw marks left by a sawing process. Definitely visible once I apply an edge banding. I'll see that if I have the scoring saw still on the workpiece. So I want to remove that. I can do that with the pre-mill, which is great. Some disadvantages, initially when the pre-milling station was introduced, the cost of it was higher than it is now. So it is an additional cost to add to the edge bander. However, the benefits of having it greatly outweigh the cost. Tooling as well, especially if we're using diamond inserts, can stack up on cost, but diamond inserts last a very, very long time, years, up to years. So like we had talked, what determines how much the pre-mill is going to remove? And that's the in-feed fence. This is going to keep our board straight. This is why I always want to press my workpiece up against the in-feed fence. And if the machine is equipped with a pre-mill station and the pre-mill is turned off, then this in-feed fence is going to have to be set at 0. Now, for all machines that have a servo in-feed fence, this will automatically be set to 0 when I turn the pre-mill off, which is great. However, if I have a manual in-feed fence that requires a ratchet, then I'm going to have to set this at 0 when I turn my pre-mill off. I don't want the board coming in contact with tooling that's not spinning. So my adjustments, this is the newer controller PC23 panel over size. What we're talking about here is my fence movement. So how much I'm going to take off with my pre-milling station. Very similar PC22. Layout's a little different, but panel oversize. Here you can see we're taking off 3 millimeters. And on the smaller edge banding machines, we can see this is defined as edge thickness. So currently, joint measurement. I'm sorry, this is improperly labeled, but we're looking at joint measurement. That's going to be the amount that I'm going to take off with my pre-milling station, the amount that my fence will move. So let's talk about backlash. Backlash occurs when I have two threads on top of each other, and I'm mainly concerned about backlash whenever I have a manual adjustment. Servos automatically compensate for any backlash, but let's kind of talk about what it is. So adjusting my in-feed fence in. So when I adjust my fence in, as we can see the yellow arrow moving left to right, we can see that my threads are pressed against the left side of the flank on the bottom. When I adjust my in-feed fence out, they're pressed against the right side of the flank. So therefore, when I move a workpiece in to my fence, what happens? Those threads shift ever so slightly, and that gap that we end up with right there, that is what we consider to be backlash. So therefore, anytime I have a manual adjustment on the Edgebander, okay, this can apply to the fence, this can apply to other stations, but anytime I have a manual adjustment like this, I always want to count for backlash. I always want to finish in the direction of the track or to the center of the Edgebander. So here, this is where we're going to start. First and foremost, I'm going to board up what we see as MDF. Works really, really well for dialing in our pre-mill station. And I'm marking it up because I want to, first of all, I want to see if my fence is straight. So once I have this board marked, I can then introduce it to the Edgebander. I'll have my pre-milling station right now set at 0.2 millimeters. So the Edgebander will be set up to remove 0.2 millimeters, which is very, very little. But what I want to see is when this board feeds out of the end of the Edgebander, I want to see if I removed off an equal amount across the board. This is going to tell me if my fence is straight. So if I end up with a result similar to what you see, then my fence is not straight. And this is a big issue. What you're going to want to do is get a hold of a service technician who can realign your fence, straighten your fence out, which is going to produce an even cut all the way across the front of the board. And this is what we want to see, ideally. So as I turn my pre-mill on, with different settings, I may end up with different results if it's incorrectly set up. And for example, this is a look at a board from the top view of what I would see if I had one of my pre-mills out of adjustment. So what we're seeing is a pre-mill coming in, it's then leaving the board, and my other pre-mill, my back pre-mill, is not finishing it up. I can also see it in this representation as well, a bit opposite. And I can see it here as well. Now this is pretty dramatic. This could be, I have one of my motors out of adjustment. This could also be one of my motors is disconnected or has a valve that's stuck. It's actually not actuating in or out to perform its function. But what I wanted to go over in this photo was the yellow square, which is the overlap in both pre-mills. So at a point in time, roughly about 20 millimeters, I should have an overlap where both pre-mills are engaged, overlapping each other. So where do I start with this? Which pre-mill would I move? And that's a big question. If I don't know which pre-mill was moved last, I'm going to need to find out more information. Now, ideally on a board like this is what I want to see. I introduce it to my machine, my pre-mill is on, I get a nice perfect rip right alongside the edge of the board. It's nice and flat. I don't feel any bump with the pre-mills, the front and back pre-mill transitioning. I don't feel any bump in that at all. It's nice and smooth. So which pre-mill do I move? Well, what I'm going to need to do is I'm going to need to check the overhang. The overhang is how far my workpiece hangs over the track. All right, and depending on what type of machine I have, will depend on what that distance should be. So if I have a 2000 series or greater HOMAG Edgebander, it's going to be 30 millimeters of overhang. And anything less than a 2000 series, it's going to be 38. Now there are some models in which these numbers varied a little bit. I would encourage you to refer to your machine manual to find out the exact overhang amount. However, being the most common are 30 and 38 millimeters of overhang. Now, why this is important is it ensures a perfect zero line throughout the Edgebander. All of my stations inside the Edgebander have been configured from factory to expect the workpiece to hang over to a specified distance, whether it be 30 or 38. If I'm off of this line, I could see increased or decreased deflections throughout the Edgebander, which could cause station wear and a host of other problems. So how do I check this? On larger machines, I've got an overhang block, which works really great. The block is 80 millimeters, my standard overhang being 30 millimeters. I want to end up with 50 millimeters on my overhang block. So I take a pair of calipers, I run my board into the Edgebander, stop it, and I can check my overhang.
Where's that block located?
The block is located at the front of the Edgebander, right after the pre-milling station. Good question, thank you, Jody. If I don't have the block, I can measure my overhang off of the side of the trackpad. For example, in this photo here, I'm measuring off the side of the trackpad or off of a ground surface underneath the trackpad if I have the proper attachments for my calipers. But this is where I'll measure out my 30 millimeters or for instance, my 38 millimeters if I don't have the overhang block. So to relate this back to what we were talking about with the pre-milling station, if I have my pre-milling station on, it's producing uneven cuts. I can run it through the machine, stop it, and I can check the overhang at the front and the back of the board on those uneven cuts, and I can see which one is correct, which one is at my proper overhang. So this works really well. It's going to let me know which one to adjust. Instead of blindly adjusting one to get to the other, then I could, for instance, move off of my overhang. I could end up at something drastic and have a ton of deflection, or my stations perhaps could not be touching at all. So as we get into the adjustments for the pre-milling station, I just want you to understand how to determine which pre-mill to move first. Here's a close-up example of the tail of the caliper coming in. You can see we're making contact with the board edge. The tail comes in off the side of the trackpad, and I'm getting my measurement. As far as adjustments go, this is on a smaller Edgebander, but what you can see, I'm adjusting the stop nut. So as I insert the Allen wrench into the shaft, I can adjust this nut, I can loosen this nut, therefore increasing how far my pre-mill goes into the board. I can also tighten up the nut and do the exact same, reducing that amount. Now I have a nut on the back side of this behind my open end wrench, and this will determine how much my pre-mill cutter returns when it's in the stationary position. That nut isn't often adjusted. We're typically adjusting our front nut. So I hold with my Allen wrench, I adjust my nut in small amounts, always marking so I can refer back to what I had moved, running a board, and then checking it. Here I've got my air adjustments, my throttles for each individual cylinder. As I point those out, These throttles are going to control the airflow for my cylinders going in and out. And the important thing is here, I don't want my cylinders to slam. It's pretty common to see throttles adjusted incorrectly. If this cylinder slams, not only are we going to wear out the hardware components, we could bounce into the board as we cut, creating a divot. I can also create a reverberation throughout the edgebander, which can affect other stations while more work pieces are being processed at once. So basically it creates a vibration down the machine, and I don't want that. So I want my pre-mills to move into position in time and to return in time without slamming, and that's proper adjustment. Here is my height adjustment for my pre-mill. This is going to move both of my pre-mill cutters up and down. Some machines in the past had individual height adjustments for each one of the cutters. Nowadays we use one for both. And this will move both of those up and down. If I look underneath the station, I see that the up and down is controlled by a chain. This is chain driven. I also have tilt adjustments. Very rare do I ever adjust those. I have valves here which are going to fire my cylinders, and I have the ability to bypass those valves, okay, to check and perhaps dial in my float controls, my throttles. So the up and down of a pre-mill station, let's talk about that. Why? Well, it's going to depend on what type of tooling that your edgebander uses. So here we can see on the left I have a symmetrical style tool, and then on the right I have an asymmetrical style tool. And the tool on the left, we can see it has an even number of up and down shear cutters. So to prevent blowout, what I need to do is I need to position those pre-mill cutters in the center of my workpiece. So some of you may be familiar with having to adjust your pre-mill cutters to the center of your workpiece thickness. So for instance, we're running 30 millimeters MDF. I've got to adjust it to 15 millimeters if I'm running that. That is to prevent blowout. It's to give me even up shear and down shear right in the center of my cutter. And you can see on the right, I have one row of up shears, and then I have two rows of down shears. So the asymmetrical style tool does not need to be adjusted. In the particular case such as this, I can actually increase tool usage if I rotate my top row of inserts. As you can see, they're not getting used on this 3/4 inch board or 19 mil board. I can actually rotate those insert cutters down to my bottom two rows if I need to, and get more tool life, get more tool usage before I need to re-up on pre-mill cutters. So I just need to be really, really careful how I move the asymmetrical style tool. If I do move it, I can easily get off my row of up shear cutters, and I can start to see blowout on my workpiece, and I absolutely don't want to see that. So on the larger style edgebanders, first to get into the pre-mill station, this is 2000 series or greater. I'm going to enable my pre-mill hood switch, which is going to unlock the top pre-mill hood. I won't be able to get this hood off even after loosening these up until I turn that key switch. Once these have been loosened, I'm going to unhook my dust collection. I'm going to remove my hood, set that off to the side, and then I'm just going to blow this area out. What we saw in the first demonstration of adjustments were that we hit on hard stops, and this follows along throughout the edgebander, and I cannot emphasize enough that cleanliness is the most important factor. Okay, if we are using hard stops and I've got dust and debris and perhaps chunks of edge banding because I've been removing edge banding with my pre-mill, if I've got that in and around my hard stops, then my station is not able to get itself to where it needs to be. So I've often seen operators or maintenance adjust these stations before they're technically clean, thinking they're out, and then once they're properly cleaned or maybe unjammed, then the station is now off even more because it was adjusted. So first and foremost, I clean the station, I clean my tooling off, I get it nice to work on. Now, as far as removing a cutter head, these threads are reverse thread. Okay, they're self-tightening, just in case it's not tightened up. When this motor turns on, this bolt will actually thread itself and self-tighten. Removing these bushings, always want to be extra careful how I set these bushings down, how I set this tool down. Always on something nice and soft, always doing one tool at a time. As I look at the tool head cutter here, I inspect the inserts. I don't want to see any chipping. I don't want to see any cracking, any excessive wear. If I have one insert go, I'm going to have a ton of inserts that go, okay? If one's not doing its work, the rest are required to pick up the rest of the tool load, and it's going to reduce the quality of the insert even more. So as I look at these inserts, obviously looking for cracks, looking for chips. The worst type of material, once again, that I can run through this station is laminates. Okay, I really discourage anyone from pre-milling off any laminates that were put onto the board edge. It will cause drastic reductions in tool life. If you can, saw the edges off, peel them off, get them off any way possible before feeding them into the tooling, because it's very, very bad on tooling. So once I have my cutter off, before I reinstall, I'm always going to make sure everything's clean, dust-free. Remember, I don't want this to be at any different height. I want it spinning true, right? This is an aluminum tooling head, so it can be dented very easily. So please, with the utmost care, always take very good care of these tools. So as I reinstall my bolt, I can then hold the shaft underneath, grab my Allen wrench, tighten my bolt back down. And now I want to point out the color difference in these bolts. Some are different colors, some are the same color, but I want it to be known that these bolts are actually different sizes. So one might think that I couldn't get these bolts switched up. Well, that's false. I can get these bolts switched up. The shaft that this bolt goes into has a double thread. So it's a larger thread, and then deeper into the shaft, it's a smaller thread for the longer, smaller bolt. So just be careful. I can't emphasize enough. Always take one off at a time. Always keep them separated so you don't ever get them on wrong. Upside down, I've seen, swapped, anything like that. I always want to make sure they go back on how they came off. So looking at the air lines, very similar to what we saw on the smaller machine. My valves, let's actuate these valves in and out. These look pretty good. I see a nice smooth motion going in. I can see the throttles on top of the cylinders where I would adjust those if I needed to change the speed of those motors going in and out. Here is my incoming air. Some pre-mill stations are different than others, so I would refer to your machine manual for incoming air specifications. Here on this particular unit, I can see lubrication zerks. Whoops. And here is my grease application. So this is what I'm going to be giving one pump into this zerk once every 2 months. I want to make sure that I do not over grease this, okay? By pumping too much into this, not only am I going to use more grease, but there's the potential to blow out the roller bearings, because these two motors actually slide on small linear guides, much like a CNC does on its axes. If I come down to the side, I can actually begin to see the adjustments for each motor going in and out. And if I zoom in even more, here I can see that I have a hard stop. Okay, I have a black adjustment bolt, which is threaded into my motor block. And then I have a locking nut. So I loosen my locking nut. For example, if I were to turn my threaded black bolt clockwise, I would be taking less off of the board. So my motor would not be able to move in as far, thus not getting my cutter in as far into the board and not taking as much off of the board. Now I want to speak to the thread locker. You can see the yellow globs of thread locker. And if any of you have been to one of the edge banding classes here at Styles, I'm sure you remember that we try and mark our adjustments with thread locker so that it's not tampered with, right? Because once I get this station tuned in, should I need to adjust the station every month? No, absolutely not. Once it's tuned in, it should be tuned in unless it's been played with. If I suddenly have my pre-mill station off, or I start to see maybe a gap in the line of my edge banding between workpiece and edge banding, then first and foremost, I look at cleanliness, right? Making sure the hard stops are blown out, making sure these actuate in and out freely and they don't need grease. Then I can move into my adjustments. That's why I always use some sort of thread sealant or thread marker.
So you're saying the only time we need to adjust that is when they change tooling?
Yes, absolutely. Absolutely. If I change a diameter in tooling, I would need to adjust these, large or small. Other than that, I should not have to adjust these guys. Proper insert removal. So once I have my cutter head out, I use my Torx wrench. I always make sure that this cutting head and my insert screws are free and clear of any dust. The worst thing that I could do here is use an Allen wrench. And more than likely, I'm gonna be able to get this screw out, but I'm not going to be able to get it back in and tighten it up. The screw is going to strip. I'm then gonna have to take it to a machine shop. They're gonna have to drill it, perhaps use an easy out. It's gonna be quite the process. You have to be very careful. Remember, these are aluminum heads. So just make sure everything's clean. If you suspect that this insert screw is getting worn, just replace it. Once I have it out, the number one thing to do, clean the pocket. Okay, this pocket has to stay clean. It has to stay in good condition. So if this pocket gets marred, if it gets a burr created on it, my insert will no longer sit where it was designed to sit. So perhaps one sits high. That insert now does more work than the rest of the inserts. Therefore, I'm seeing reduced tool life. This is something that I would check for whenever I'm changing tooling. Perhaps if I have an edge bander with a couple years on it and a pre-mill cutter that's been changed quite a few times and I'm seeing one insert in particular go every single time, then I'm going to look at the pocket. Are the threads pulled out a little bit? Does it need to be replaced? So always making sure that this area stays absolutely clean. Next, I want to talk about the station adjustments on the controller. So what we're looking at here, this is on a smaller edge bander, less than a 2000 series, and we are inside the sizing motor, my pre-mill adjustments. So you can see on this particular edge bander, the only toggles that I have are turning this unit on with the check mark that we see for unit, the separating agent for the top edge, which is my spray, the separating agent for the bottom edge, which is my spray. Now I want to speak to the sprays. So if I'm using a spray system, it is designed to spray those edges with a glue release, thinking that if I have my pre-milling station turned on, that I will pre-mill the surface, exposing fresh board for the glue. But I've seen it many times where customers modify programs, this gets turned off, the pre-milling unit gets turned off, yet the sprays stay on. Okay, this can pose a big issue. You're spraying the board edge that you're going to apply glue and edge banding to. So problems are going to occur. You may not notice them. Perhaps your sprays have run out. Perhaps your sprays aren't adjusted correctly. But this is something that you need to look for if your programs have been modified. Moving on to the larger machine, I can see that I've got quite a few more options, and we're going to go through these. Joint trimming at the top left. Simply put, that is the on and off for my pre-milling station. Pre-selection tool, this contains the tool details, such as sizes and specifications for the pre-mill tool that has been used. I do not want to adjust anything inside a pre-selection tool unless I'm changing tool diameters, so on and so forth. Pre-select tool, or excuse me, pre-select motor operating mode 1, operating mode 2, internal and external. We're going to talk about these in just a second. Front edge operation motor 1, rear edge operation motor 1. So I see 100 and I see -50 internal and external. Now I'm going to advance to the next slide so that I can further explain what these mean. So here we can see if my board is being fed from right to left, in this example, I have two pre-mill cutters. One does the rear, one does the front of the board. So I can actually see that these pre-mill cutters, one is defined as internal and one is defined as external, which is what these options are right here. So I can change these from internal, I can change them from external, I can actually disable one of them. If, for example, I ruined a pre-mill cutter head, I didn't have a replacement and I needed to run one pre-mill cutter, I could turn one on end to end, which is another option inside of this. I could disable the other one. Now that pre-mill cutter will go all the way across the entire board. We didn't talk about it much, but I use two pre-mill cutters because they turn opposite of each other. And I do that to prevent blowout. So as the board comes in, I'm cutting opposite of the board feed to prevent that blowout off the board edge. So you may be thinking, if I use one cutter to go all the way across the board, I may end up with blowout, which is true. However, in the instance where I needed to run, I only had one cutter. I do have that ability on this machine, which is really nice. So the values below those, 100 and -50, advancing forward, I can see those are defined here at the top. 100 millimeters away from the front of the board edge, we can see that my internal pre-mill cutter will advance away from the board, not cutting the front edge, until -50 away from the tail edge of the board, it jumps in. Same thing for the other motor. My external motor, 100 millimeters from the board edge, jumps in, cuts all the way across the board until -30 millimeters from the tail edge of the board. Now each edge of the board, if I'm always moving towards the center of the board, I'm moving in a negative manner. So we could see on the left, 100 millimeters, obviously positive away from that board edge. On the tail edge of the board, -30 millimeters, moving in towards the center of the board, negative value, ends up at -30 millimeters. What can I take away from this photo? I can see that at -50 and -30, that means that those are overlapping by 20 millimeters. I could change these if I wanted to, if I needed to for some specific situation, disable or enable one motor. Those are some of the options that I have with this pre-milling station. Last but not least, I don't want to leave out the sprays that we had talked about. Here they're located before the pre-milling station. I spray that board edge with the glue release. I mill off the workpiece surface, and then I get good adhesion. I don't have any glue, perhaps that squeezes out after I apply the banding. That doesn't stick. That is the purpose of that glue release spray. These can be adjusted for the amount of spray that I wish to apply by the turn knob, the black turn knob. And I can clean these out by simply using a paper clip, the end of a paper clip. I've seen these jammed up, clogged up. They do need to be surfaced from time to time, especially if you work in a dusty environment. So once again, my name is Seth Jagger, teaching Edge classes. We have some coming up in Grand Rapids over the next couple months throughout our other locations. We're going to take this time to answer any questions that you guys may have on any of the content that we had covered. If you're watching this webinar later on today, not live, for instance, you can feel free to email myself at sjagger@stylesmachinery.com. I'll field any questions that you may have about anything that we went over with today. Once again, Edge.
Sorry about that, Seth. I'm moving a little bit too fast here. I believe you were going to show everyone where they can locate the product specialist in their area.
Yeah.
If you want to.
Yeah, no problem. Do that. So once again, Edge product specialists throughout the United States. Marty Jones covering the Midwest, Jeff Tolbert, the Northeast, Dave Schmidt, the Southeast, Dylan McNally, the South Central, and Lucia Morales on the West Coast. So feel free to reach out to them if you have any questions concerning your Edgebanders, or if you're interested in any rebuild services, excuse me. For instance, glue pot rebuilds. We do glue pot rebuilds. We do motor rebuilds. That can be on your pre-milling station. That could be on your Wiki CNC. It could be on an end trim. It could be on a fine trim. We do a lot of those rebuilds here in Grand Rapids. Very quick turnarounds, so feel free to reach out to us. The website's listed here, email's listed here, and phone number as well listed here. So that is all I have, and we'll leave this moment to answer any questions.